Okay, so today is our second class, our second session of C programming tutorials organized by the TraTech Committee of ELISA. Yes, so um last on Saturday we got familiar with some things with the code blocks ID um with our compiler, variable naming, types, some operators, and data input and outputs. We'll put the slides or some materials. I've not been able to do that yet, but we'll put it in the Google Classroom so that you can uh, get all the most of the operators. Yeah, basically, yeah, on the operators. Yeah. So today we are going to focus on um control flow or how you can control the flow of your code. And I'm going to basically deal with decisions and loops. So you know about decisions already. Your if else statements, loops, your while loops, your for loops, and then just a bit more that are maybe exclusive to C. Yeah, so let's just jump straight in. So I hope that we have our IDE open. Yeah. So let's just jump straight in. So the first thing we'll look at is just try to spend about an hour to go through this. Then we just, as we learn each concept, then we just try an example. So we'll start with decisions. So basically, you in your code, you want to make decisions when some conditions are met. In a lot of the logic that you'll be writing, or in a lot of tasks that you want to complete your code, you want to perform some task or let the computer do something for you if some other parameters meet some condition. And you usually fulfill this with decision statements, with if else statements. So this is very fundamental in most code that you write. So let's just get right into it. So we have if statements. Basically, C programming is high level language. So it just goes as it says. If this happens, do this. If that doesn't happen, do that. So if this happens, else do this, else if do this. So the syntax is
Please, I'm not seeing your screen.
is said
I'm not seeing your screen. The screen that you are sharing.
uh, okay. Is anyone also experiencing that problem? Yes. If you can see my screen, just react. If you can see my screen. Yeah. Yeah. I think some people can see my screen. So if you can leave the meeting and join again. Okay. If that doesn't work, then uh,
I can see now. I can see.
okay, sure. So let's just try some. So if condition, so in C, this is the syntax for an if statement. So if something here is true or is fulfilled, then run the command in this brace here. Else, then another curly bracket open. Else do this command. And you can also have an else if. Else if maybe then the condition, then you do another command in the curly brackets. So that's the syntax for it. So let's try an example here. So you can you initialize maybe I to be, let's say, 5. Never don't forget your semicolon. So if I equals 5, don't forget your semicolon. As you can see here, this when we're dealing with the operators, relational operator, that this one equal to means it is an assignment. You're assigning some data type to a variable. That's one equal to sign, but two equal to signs mean it's equal to something. Yeah, so take note of that. So else print if um if the number is not 5, don't forget your semicolon. So what is happening? Okay. So our int main function here, our return 0 here. This is the basic skeleton of our code. We've assigned the number 5 to I, which is an integer. Yeah, like this. So we are saying if I is equal to 5, do this command. So if the condition is in the brackets, and then the command that you want it to do, if that condition is fulfilled, is in the curly brackets. And if that condition is not fulfilled, do this. So that will come else, and then the curly brackets, and then your command. Always when you write statements like this, they come with a semicolon. But for the if else statement structure itself, there's no semicolon. It's just the brackets and then the curly brackets. The curly bracket is where your command will be at, where the main code will be at. And then this bracket, the normal bracket is where your condition will be at. Yes. So you can run this now. Yeah, so it printed out IS5, obviously. So yeah, this is the syntax for an if statement or an if else statement. We can also have an else if where down you add a condition. So if maybe I is equal to 6, do something. And so your command will be in the curly bracket. So you can have a bunch of else ifs. If I equals this, else if I equals this, another else if. You can have a bunch of else ifs with different conditions and then different commands here. So maybe you can ask your user to input something, and then you save that into a variable. Then you use uh, an if else if structure to determine what command will be executed. So that's a very simple basic control flow. So you can just try an example, then we'll move on to our next decision statement. So let's say So we can initialize age, right? Yeah. And then we want to ask the user maybe what is your age, right? So you want to print if what's the age? And then you want to take inputs from the user. So remember how scanf works, right? There's a control string for an integer. The control string is %d, and then you want to take whatever the user inputs into the input stream, and then you save it at the address of the variable we've initialized the age. So you take so you the control string plus the address of age. So this is the address operator. So basically, you are telling the compiler to take whatever the user put into the input stream. It's going to be an integer. That's what the control string is basically doing. Save it at the address of where age is at. Save it at that address. So now age will be assigned whatever value the user puts in. So after that, we want to check maybe some few things. So if age is greater than 5, uh, print maybe um, don't forget your semicolon. Else, if maybe age is less than 5, you print don't forget your semicolon. Every time I listen, I don't know how to deactivate it. Don't forget your semicolon. So basically, yeah. Okay, I've explained this part of the code. So if age is uh greater than 5, do this. Else, if age is less than 5, do this. If well, it's going to be either of them, but then if maybe the user puts in 5, then maybe I'm going to print you didn't follow the right instructions, something like that. Then they have this. So it is if condition statement in the brackets. Else, if another condition, you have your curly brackets, that's your statement you want to input if the condition is fulfilled. And then else, if none of them, just do this. Yeah, I'm coming. Okay. Yeah. So I hope that you've tried this. Uh, so if age greater than 5, let me repeat. If age is greater than 10, print you're an adult. If age is less than 10, print you're a child. Else, you didn't follow the right instructions. Yeah, something like this. So you can link your code and run it. So then I input maybe exactly 10 inside. Mm, Code else if else, and that is running. Yeah. So you didn't follow the right instruction. I think the one I was running before, I didn't link the after I changed it to 10, I didn't uh I didn't link the code if I ran it to. Yeah. So it was still running the old one that was compiled. We talked about compilation, changing the source code you have here to machine code, and then running it as an executable file. Yes, basically this is how an if else statement works. You can have a bunch of else if. So if this like a lot, so it can be like a option that you choose from. If any condition is fulfilled. Yeah. Then the next thing I'm going to look at is a switch case structure for decisions. And it's not like I don't think you've seen that in C, but then it's just similar to an if else statement. But yeah, it's basically options to choose from. So let's just look at the let me comment out this code. So we said to comment the forward slash and asterisk, and then yeah, another one. Okay, so a switch case is switch and then case. Let me see, choice B, nice way to be. And then I'm going to have case maybe one, and then your command will be here, and then you use a break, and then have case two, and then a command, then you can break your code, and you can have case maybe three, and then command, and then you break your code. And you can have a default situation, and then a command, and then a break. Okay, so this is the syntax for a switch case. So basically, you have a choice here, and then the choices will be here. So if your choice is one, it will go to case one, execute your command here, and then it will break. So a switch case is like if else if like but the else is are a lot. So like if case one do this, else if case two do this, else if case three do this, and then else so the else will be your default. So if none of the cases are fulfilled or there's not any of the cases, you should just execute the default command. So it's like it's giving you a group of options to choose from. and that will be determined by what will be here at choice, and then you can execute the command. So the choice here, and which will be can be any of these one, two, three, can either be an integer or a character. So it limits it a bit because here you can see that for the if statement, we are um looking at conditionals and relationals. You can say if age is greater than or equal to, or you can be more flexible with if else statements in their condition. But for a switch case, you can just have an integer or a character. So it just makes this one a rigid option. But then a smooth one as well because then if maybe you don't want to like write a lot of code and maybe you just want to choose between a group of some set of choices one, two, three, four, five, A, B, C, D, then you can use a switch case and a switch case will be better than writing if maybe I equals one, do this, else if I equals two, do this, else if I equals three, do this, else if I equals four, do this. And your else statement, that's more code. You can just use a switch case to do that. So let's try an example with a switch case. So if I remember, I say choice equals three. So then I've initialized choice, and I'm saying I've assigned it to three. So you can do this. You can initialize first, then you can assign later, like this. But then it's just better to do them combined, right? You initialize, you are saying that this um, variable name, this identifier is going to be an integer. You're telling the compiler that then you assign it to the number three. So then if the choice here, so choice here is going to be three, definitely. So it's going to go to case three, and it's going to execute the command that you have put here as case three. Right now, the only command that we know to execute that we can verify our data outputs. So that's what we've learned so far. So let's just take data output, and then as we continue to learn more functions, we continue to improve our code and make it more complex. So just print if pineapple. I really don't know to put you. And then you break. And then if it's two, print if. Okay, let me just say if it's one, number is one. Okay, number is two. Number is three. Don't forget your semicolons for the commands and then the break. So yeah, this is the syntax for a switch case. Case one, a colon, do this command. When you're done, break. Case two, do this command. When you're done, break. Case three, do this command. If it's case three, break. If it's none of them, do this. So the default, do this command. Yeah. So you can write it as a line like this, or you can even put make a space like yeah. It doesn't matter how you do, but then usually you see a lot of code and then it's uh spaced out like this. Sometimes so that it's more you can see it easier. You can see the flow of your code easier, and it just looks better. But then you can write it like in a straight line it's same for the else. If you can even bring the else here and then put everything on the same line, it it will still run. Yeah. And then the indentation doesn't really matter too. Like if you bring this one here, you bring it even here like this, it will still run. Your code will still work. But then just better presentation like this. So this is how for a switch case. So if I assigned three to choice like this, um so switch choice, yeah. Case one, do this command. No, don't forget your semicolon. You break. So the break is here because you don't want your code to fall out. So after I done executing the command I want you to execute because this condition has been satisfied because it is case one, I am done with you. If you leave out the break, the code you are going to fall out. So because case one has been fulfilled, because it's case one, it's going to execute this code and it's going to continue to execute this code until a break is met. Because it will be if the break is not there, it will be like this case two is under case one. And then since case one has been fulfilled, there's no break there. I'm just going to continue executing the commands line by line. So the break there is very necessary. Never forget your break. Good. And I also said the choice can either be a character like this, maybe A like this. So case A, case B, case C, case D, or integers, case one, case two, case three, case four. So you can already see its application, right? If you want to choose, if you have some alternatives you want to choose from, or you want the user to choose from. So you can label that maybe, okay, we'll try the example after trying this. So this is the basic syntax for it. So you run it. Let's run that. So the number equals three. Yeah. Okay. So let's try something with a user input. So I'm go with the same in choice. This time we want to take the assignment for choice from the user. So we will just initialize it and then we'll um uh, maybe make a choice. Don't forget your semicolon. Then we're going to do that printf. Um uh, so maybe option one is don't forget your semicolon. So This backslash and n that I use here is so that it will go to a new line. So after printing apple, it goes to a new line before it prints bananas. So these things are called escape sequences that you can use in your print statement just to format your text and make it like maybe appear nicer. So a list of escape sequences will be put in a Google Classroom. But then usually you'll be using maybe a backslash and an N for new line, and then backslash and a T for tab, which will leave a horizontal space. So we use this one. So it will print apples, new line, bananas, new line, strawberries on a new line. After that, you want so the user is going to put in a choice, right? So let's put a new line here so that the user put the choice as a new line. So you're going to use our scanf. Remember your control string. What are we expecting from the user input stream? We are expecting a um an integer. So our control string will be a percent d, and then we'll attach the address of choice, right? Don't forget your semicolon. So now when you put in these, then you put a scanf there. You are telling uh you are telling the compiler that um the user has come to put something into the input stream, to take that integer, put it into choice. So now you want to, based on that choice, you want to execute some command based on what the user preferred. So you can use you can clearly see here that it will be best to use a switch case and an if else and is if else if. So for an if else if you're going to do if choice equals one, do this. If choice equals two, do this. So you can see that your code is small. But you can just do a switch. Let's put in choice here. Your curly brackets, case one, um, print f, going to print f, and then you can break, and then have case two, going to do a print f, maybe, I don't know, um, and then you break because enter has fulfilled what you wanted to. A printf, maybe, and then you break. So it's always good to add your default, right? Because then if maybe the user doesn't input a number or he input four, what's going to happen, right? So then you can put the default there. Then you execute the command. So the default usually be like the error message. So you didn't follow the or you didn't follow the instructions. Then don't forget your semicolon and don't forget your break. So just to make our code look neater, bring this here, uh, bring this one down. Okay, bring this one to down, and then the default choice. I'll bring this one down and this one to down. So you initialize your variable, you print. So what's your favorite fruit? This is an escape sequence. You print this out. You do this scanf, right? And then it's going to save the number the user put in a choice. So then you take that choice. Uh, it will pass through a number of cases. If your case fulfilled, it will do the command you've put there, and then your code will break. The break here is essential. Otherwise, there will be something called a fallout of your code. Your code is going to continue to run the rest of the you can try it out. It's going to continue to run the like rest of the statements because it will take it as if since case one has been fulfilled, I'm going to execute all these commands, right? Because then yeah, exactly. You're going to execute all these commands. If your break is not here, so you put your break here, you put your break here, your break and your break. Cool. So if maybe I name this one break, you see, you can't name this break when we're talking about uh our the variable names or the identifying names that we can use. Right? You can't use keywords. So break is a keyword, so you can't use break. So any of these words that are highlighted, you can't use them in naming your variables. And yeah, yeah, exactly. So you can run the code now. Mhm. Yeah. So you see, after because of the escape sequence I use here, the backslash n, which will send me to a new line. I go to a new line after I print what's your favorite, it goes to a new line. Uh, prints out apples, goes to a new line, prints out two bananas, goes to a new line, and then three strawberries, right? And then it goes to a new line so that the user can make a choice, right? So I chose for which is not now any of the case, so to go directly to the default, which will print out you didn't follow the instruction. So basically that's it for switch case and if else statements. So I'm sure we are familiar with the syntax now. We are going to continue with loops. So this is it for decisions. Basically, these are the main decision structures that you can use to write a lot of code and get more creative and solve a lot. You can solve a lot of problems just with if and else ifs and switch cases. Yeah, so basically this is for decisions. These are the main decisions that you uh structure that you'll be using. So let's go to loops. Let's continue with loops. So I think that we've got I want to delete the code so that we can I don't like the plenty code here. So I'm sure by now we have the structure of how they work. So for a switch case, switch your option, the choice here in this bracket, your curly bracket where your proper code will be at case one, colon, command, don't forget your break, semicolon, your command, don't forget your semicolon, case two, colon, you print this, don't forget your semicolon, break, don't forget your semicolon, case three, then put it down. And then your default, if the user doesn't or whatever thing it is, if it's not any of the cases, you usually will not be able to satisfy all the cases. You need to put a default here, best practice, colon, you print F and break, and then this is your skeleton. Yeah. So I think that's it. That's all. And then your else if condition brackets command, don't forget to semicolon, else if condition brackets command, don't forget to semicolon, else is like the default. If everything has been exhausted, if it's not any of them, do this, right? Exactly. So yeah, I think that's it for decisions. So we are going on to loops, fun loops. So loops basically have two types of loops. You have the for loops and you have the while loops. For loops are when your number of iterations is predetermined. You know the number of iterations. So you want to loop through or you want to do something n number of times where you know n. You probably be using a for loop. While loop is basically till some condition has been fulfilled or some condition has been negated, something like that. So while this is true, do this. While this is not true, while this is less than this, while this is greater than this, your relational operators and stuff. While this, do this. If it's not that anymore, don't do it again. That's all for a while. But so for a while, the number of iterations you may know sometimes, but you usually may not know. So if you are thinking you are about to solve a problem and you want to do something a repeated number of times to check if something is true or not, but you don't know the number of times that you should loop through or go through your command that you've put out in the code, then you should probably be thinking of using a while loop. So then yeah, so you should be thinking like that. But if you know the number of iterations, you want to do something this number of times to fulfill or to accomplish some specific task, then it's best to use a for loop. So you can just be thinking like this. If we go on to solve very specific problems, we can be thinking in this mindset. But right now, we just want to get familiar with the syntax. And then as we continue to solve real problems, we'll look at uh, the direction of while loop for loops. But then you can know right now that for loop, usually 100% of the time, you know the number of iterations. For while loop, you usually do not know the number of iterations, but you know the condition that must be fulfilled or must be put against. You don't know the number of iterations, but you know that I must be whatever you're doing, I must be greater than five. Once I is less than five, once I is less than five, then stop doing any operation that I put in the code. Exactly. So let's look at the syntax of that. I'm deleting this now. So let's look at while loops first. No, let's look at for loops first. For loops. Yeah. So for a for loop, yeah, going to have this and then the brackets. So for the flow of control or the control flow, you see that they have a similar structure. Um, the normal bracket here and then the curly bracket where your actual command will be at, where you are doing the actual proper code will be at. So initialization, a condition, and you increase or decrease. This is the basic structure for it. So if maybe you want to do a printf, you want to printf, I am a girl 5 times, you maybe initialize I, so initialization, I to be equal to 0, and then your condition is I should be less than 5, and then you increase I. So this is it. If you want to do so, usually there, since your number of iterations is known, let's say n is known, it will usually be done here, right? So we want to go 5 times, 5 iterations. So I should be less than 5. So basically, you initialize. So you go initialization, then your semicolon, then your condition here, which is usually which usually give you a hint, or where you usually determine the number of iterations you want to, and then another semicolon, and then uh, your increment, because you want to go a number of times to uh get to like your limit. So what's going to happen here is that you initialize I to be 0. So when we are going I is 0, right? 0 is less than 5, right? So it will print this. And then you go again. So after 0 is less than 5, you do an I plus plus. So now I is 1, right? So I is 1 less than 5. Yes. So to print I am a girl again, that's two iterations. And then we'll go again. Now I is 3. It's 3 less than 5. Yes. So to print I am a girl. And then 4. That's 3 iterations. It's 4 less than 5. It's 3 less than 5. Yes. Add another one. Now we have 4. That will be our fourth iteration, right? And then to increase it to, then the fourth one is 4 less than 5 years, increase it to 5. That'll be our fifth iteration. And then it's 5 less than 5. No. So you are done. So then yeah, you are done with the number of iterations. And then things similar things like this will become in exams, right? And then we ask you how many times so I am a girl be printed onto your output stream. So basically understanding what is actually going on here would help you much. So you should take note of this. So if maybe if I was less than or equal to 5, then to do 6 iterations. Or if I initialize I at 1, you need to do maybe 4 iterations. So then this changes wherever it's initialized changes. So you should know how to flow with the code, know how to read the code line by line, so that you can be able to answer this kind of question that will come a lot in your exams. So yeah, let's run this. Let's see how many times I am. Let me put an escape sequence here, new line, so that to print it like so that yeah down. Uh, each I am a girl and a new line. Yeah, so run this. Yeah, so you did it how many times? 5 times. Exactly. So if I maybe put I equals 1 year, right? And I say I equals 5 year, how many iterations will, or how many times will I am a girl be printed onto our output stream, onto our terminal? Please put it in the chat if anyone is following. Okay, I think someone said four. Okay, so let's try and let's see how many times that will happen. Okay. So it printed it five times. It printed it five times. It didn't print it four times. Okay, someone said five. So let's see why it is five. And these questions come a lot in your exams. So it's very important you understand it here now. We'll try a lot. Yeah, we'll try like three more until like everyone here is getting it right. So let's see why it's five. Okay, I hope it's five because it's pretty five. Well, yeah, it's five. So you initialize I to be one, right? So I is one. So I is one. Is I less than or equal to five? Yes. I plus plus. So now I is two. So to print this one, that's your first iteration. You down one. Now I is two. Sorry. So we done one iteration. Now two is two less than five. Yes, two is less than or equal to five. So now I plus plus. Now I is three. We done second iteration. Now I is three. I is three less than or equal to five. Yes. So third iteration. And then we increase it to four. So now it's four less than five. Yes, four is less than five. So we'll do our fourth iteration. And then now we have five. Is five less than or equal to five? Yes, five is less than or equal to five. So now I is six. And then we have our fifth iteration. So now we have six now. Is six less than or equal to five? No. Condition was not satisfied. We don't print again. We are done. Do you get it? So then it's going to have five iterations. So let's do this. Please put in the chat how many iterations we have for this. How many times will I am a girl be printed out? And this is all about for loops. So then the command that you can be manipulating, and if you understand this, you can be manipulating the I as well. Um, the condition can manipulate your condition. Here can be an increment or a decrement, but then there should be some increment so that you can be moving along, right? So the condition is not fulfilled. Because if there's no increment, then I will be maybe two, and then your condition will always be fulfilled. And you'll be like printing some, right? But no, we want so you need to be increasing it so that we iterate for a number of times. And sometimes so just better start your I with zero and then your defined number of iterations here. But then solving different problems, maybe your I may change. You may want your I to be at some certain place, and then your condition to be at must be at a certain place. So with your initialization and with your condition, you should be able to determine how many iterations you'll be going. And then this will also come out in your exams. If not for anything. So you need to understand. Yeah, let me see in the chat. Yeah, so three, yeah, three. Okay, three. Let's see whether to be three. Let's see whether to be three. Yes, three. Yeah. So it looks like we are understanding. So for those that will be watching the video, let me just explain it. But it looks like Ash Princess is understanding it very well. So for we've initialized I to be two. So we start at two, right? So it's two less than five. Yes, 2 is less than 5. Now we increase 2 to 3. We do we print 1. And then now I is 3. Is 3 less than 5? Yes, 2. We go again. And then I is 4. Is 4 less than 5? Yes. Now I is 5. We print again. That's 3. And then is 5 less than 5? No, 5 is not less than 5. So then you should also be taking note of your whether it's less than or it's less than or equal to. And then if you understand basically this, I think we are good to go. We are good to go for 4. So you can add ifs in your main command and stuff like that. You can manipulate. But then this is the basic syntax. You have your for here. You initialize the variable that you want to increase or that will control the number of iterations. You have your then don't forget your semicolon. You have your condition here. Don't forget your semicolon. Then you have your increment here, and then you have your curly bracket. So mainly the curly bracket is where the main thing is going on, the main code or whatever you want to execute to the output stream or however you want to manipulate something will be at. So that'll be at the curly bracket side. And then you can that'll be at the curly bracket side. Yeah. So that's it for F4. Let me just leave this here first. Okay. So let's go to the our next thing. I'm going to wow. So we said while is maybe we don't know the number of iterations, but we know that this condition must not be violated. So maybe so the basic shelter is while condition condition and then do some stuff and then uh you want to do some stuff. Then after that you usually have an increment, or then maybe you're doing some stuff to have an increment because you need an increment right to the condition. Because if maybe you want whilst number of footballers is not while maybe number of while number of footballers is not greater than maybe 7. You do some stuff here, right? Yeah. So you have to be increasing it. So whatever stuff you do here, maybe after doing that stuff, the number of footballers will increase. So you perform an increment. Then you can check your condition again. So the condition fulfilled. Because if you don't have any source of increment, any form of increment in your code in the curly bracket, then that means your condition is going to be constant forever. So you need to check this. Or maybe you want to run a while loop forever. So that would be maybe while true, because the condition must be true for it to fulfill, right? So maybe we said earlier that 1 means true. So we can say while 1, do this, and it's going to execute it forever. But then we usually don't want an infinite loop, right? We want to control our code and the flow of our code. So while some conditions have not been fulfilled, then you stop. So while the condition is true, continue to do it. You may be increasing, not necessarily increasing, but manipulating uh, whatever variable you have. So that once the condition is not fulfilled, then to stop. Once the condition is full, then you stop. So that's how our loop works. While this, do this. So if it's not again, don't do it again. If amount is the next 2 minutes, if you have any questions on what we've learned so far. Okay, no questions. Uh, yeah. So my recording, yes, I'm recording. So let's try something. So, um, wow. What? I should have gotten some. s- specific problems. So maybe we initialize um I to be equal to one. So while I is less than or equal to 5, you're going to do a printf. Maybe you're going to print. Okay, let's print I. So I is an integer, so percent %d, and maybe we want to do it on a new line. And then you put I here, don't forget a semicolon. Then I plus plus, don't forget a semicolon. Let me do this. Okay, so okay, so while this condition, do this I plus plus, so increase I by one time. Okay, so let's see how this goes. We initialize I to be equal to one. So while I is less than or equal to 5, print this. So you're going to print I. So I is 1, right? So the condition is I is 1 less than or equal to 5, yes. So you're going to print I, and then you're going to increase it till if the condition is not fulfilled, then you cut it out. So then for these decision statements and loops, you should be able to know how to read the code, go through the code line by line, follow the increment wherever it is at, and then test the condition, do the because that's how your exams. I'm sure that's how your exam is going to be. Because C programming wrote, I think we did objectives. So there are going to be options there and they are going to be closely matched. Right. So if you don't know how your code is flowing, you will struggle. Right. So then you should be able to know how to read the code line by line. Be reading it to yourself. Right. Receiving the I, writing it down. What's I? And be going through the code uh, line by line so that you can be able to get the right answer. If you're able to do this, you'll be good to go. So let's run this. So you printed 1 to 5. So I start as 1. So to print 1, and then I is now 2. To print 2, I go to 3. To print 3, I go to 4. To print 4, I go to 5. To print 5, and then it goes to 6. Then it won't because then the condition is not true. So basically, here must be true. Whatever condition here must give you true. If it's not true, then yeah, kicked out of the while loop. Then we go on to the next line. So this is the structure for a while loop. Yeah. So I think yeah we covered most things. Yeah, most of the control flow. This is the basic syntax for them. We'll dedicate our next class just to solving proper examples, where we will be combining while loops, for loops together. We'll be thinking through the problem. The first will be 30 minutes of our next class. The first 30 minutes of our next class, we just be focusing on we're solving a particular problem, a really tough problem, with just while loops, for loops. And then you see how powerful they are, and then how useful they are. And usually that's what you need a lot in your code. So we solve like a tough problem with for loops, while loops, um, if statements, maybe a switch case together, so that we can understand it and then maybe target like a really real problem. So you need to get familiar with the syntax first, and then they are similar syntax. So all that we got for the while loop. That's nice. So the next thing is a do while. So a do while loop is basically like a while loop, but to do it before you check, to do at least one iteration before you check the condition. So you are assured of one iteration. Maybe if you are writing something, you're not really sure whether your command is going to execute. You just want to check it before the conditions are checked. So to perform one iteration of your code block, your command block, your real code in the curly brackets before it will check the condition. So it's just like English, right? Do this, do then wow, the condition. Ugh. And the condition. And it will be your command. So do some things here. Wow. So the condition be here. So the other one was wow. Let me just do that again. So wow, then your command here. But it's like do this, then wow. So like just try whatever I've said first. Just output it first before you check the condition. I just want to know that to output something that I expect before you check the condition. So that if maybe I debugging, you know that okay, the problem is not maybe with my main code, maybe it's with the condition or it's maybe somewhere else. And then you would, if you know how a while loop works and how you do while loop works, you would just know in whatever situation you're in writing code or in solving some particular problem, which one you would need. So this is how they do all this. Like, so let's try the example that we tried, a similar example. Let's see all I'll get the same 1, 2, 3, 4, 5. So in that one, we said we initialize I to be one, and we did a print if here. Wanted to print something. Our control string is telling us what will be coming there. What will be coming there will be an integer. And then where is it going to fetch that integer from? We're going to fetch it from I. And then to do this first, then to start checking our condition. So basically, a do while loop is like a while loop, but then to execute the command just once first before I start checking the condition. So do this while. So it's like a while loop with an extra iteration where that extra iteration is not conditioned. Right. So we have this. So what was the condition that we used? I think we said I should be less than or equal to 5. Right. Yeah. Mm, I think so. Let's see what. I didn't. Let me add the. So you see, because I didn't add the escape sequence for new line, it just printed it together. Okay. So you printed out 1, 2, 3, 4, 5. So let's go. So then I is one. I is one, right? I is one. Uh, and sometimes the I plus plus can be, yeah. So you okay? Let's finish with reading trying to read the code line by line. What's happening? The increment, and then how does it go to our output? So every time you write some code, try and predict your output by just reading the code line by line. Because that's how your exam is actually going to be like. You're not going to have the compiler. You're not going to have an ID to run your code and see what happens. Then you use that to determine how your code was actually run. You just be having possible answers to choose from. So then, if you know, think like the compiler. If you know how your code runs line by line, then you can select the right choices. So I is one to print one, and then I becomes two. It's two less than or equal to five. Yes. Uh, then to print two, then increase it to three. Then it's three less than 5 years. It will print go to four. Yes, print four. Go to five. Less than or equal to 5 years. Print is go to six. Is the condition fulfilled? No, the condition is not fulfilled. We don't print anything again. So now let's see if the I plus plus was here. Right? Yeah. So you can see here that it goes from uh 2, 3, 4, 5, and 6. Right? You can see that it goes to six. But then yeah, I should be less than or equal to 5. So why does it print 6? That's so weird. Why does it print 6? By just changing I plus plus from I just below the printf to above the printf, our output changes, right? And then these options will be in your possible answers. Right? The same, you've seen some before. We initialize I to be one, I is less than or equal to five. If I is less than or equal to five, I will never be six. So why? Why is I six here? So let's go to it, the code, right? So then we initialize I to be equal to one. So you need to go to the code line by line. I is equal to one. Because when it's executing the zeros and ones that it compiled to, it's not going to execute it from the bottom up. It's going to execute line by line, right? Following the syntax that has been defined. So I plus plus I will become two. So to print out two first. Is two less than or equal to 5 years? I plus plus I becomes three. Print out three. Three less than or equal to 5 years. Then we go again. Four. You print four. Is four less than or equal to 5 years? Then we go again. We print go 4 plus plus so 5. Is 5, so it's print 5, right? Is 5 less than or equal to 5? Yes. Then to go again 6. It will print 6. Is 6 less than or equal to 5? No. Then it will come back up. Then it won't come here again because then the condition has not been fulfilled anymore. So you can understand why we have 6 because we had after the increment we printed it out before we checked the condition. So just with where your increment is at, it's if maybe you wanted it to print only when I is less than 5, just because of the position of your I, your code was able to skip that. So per the code you've written, it has executed what you wanted it to do, but not what it has executed what you the code you wrote it to do, but not what you intended to do. So you should be able to read the code line by line, right? And understand each function, what's going on at each step, right? So basically, this is it. This is it for today's class. We've learned control flow. We've learned decisions and loops. We looked at if statements, if else statements, if else if statements. Uh, we've looked at switch keys, right? We said for our switch keys, we should not forget the brick, right? And then for the choice, now put in a normal bracket. We should know that it is going to be either a character or an integer. So then we are a bit restricted compared to if else statement, because if else you can use like relational operators and other operators and stuff. You can be more dynamic and have fun in the brackets. So switch case is more original and just usually for maybe choosing between some set of choices that you have. And then that when a switch case will come in. And then we went to loops. And then we started with for loops. We said for loops usually we have a defined set of iterations. We know if the iterations were n, we know what n is. So we'll use a for loop. And we look at the syntax for a for loop. I think we are good with that one. You have the initialization step here, your condition here, and then your increments or decrements, or yeah. So then you can, since you know the syntax now, we spend a lot of time on the syntax for each of them, and then so you can just go and look at play around, try to change this to three, maybe change this to less than or greater than, equal to, see what happens. See what happens. You can, whatever happens, or if maybe something is happening that you don't understand, you can text it to me. You can put it in a group. Okay, maybe you try this will happen. Right? Why did it happen like this? You can just be trying different things on your own. The more you try, the more you get familiar with the syntax. That's for four. We did whiles and do while loops, iterations. Then that we don't know the final of iterations are for while loops and do while loops, right? Do while loop is just a derivative of the while loop. So for while loops, and yeah, so there's a condition we look at this. So go and play around with them, with the increments and decrements, stuff like that, with different commands. And maybe put a scanf here to do something. Let's see how that goes. Yeah, so that's it for today's class. Thank you for joining. Do you have any questions? Okay. Does anyone have a question? Okay. Thank you very much. That's the end of the class.